Hey there, my name is Taylor Price, and my final project is on lysergic acid diethylamide. Its conventional name is lysergic acid diethylamide, as I already mentioned, but it is more commonly known as LSD or LSD-25. However, you may be more familiar with its street names: Acid, Pearly Gates, Mellow Yellow, Sunshine, and so on and so on. Its IUPAC name is pretty long: 6A-R-9R NN diethyl 7-methyl 6,6A-8,9 tetrahydro 4H indolo 4,3-FG quinoline 9 carboxylamide. Molecular formula is C20H25N3O. Down below, you'll see three sets of structures. The first one is the wedge and dash notation, which represents the molecule's 3D structures. The second one is the ball and stick figure, and the third one is the space-filling 3D molecule. I've attached a link here that if we click on it, it'll show us the 3D molecule of LSD in space. So it's going to spin around for a little bit, and then as soon as it stops, we'll be able to see the molecule in space. Moving on to our functional groups, our first one is an amide group, which is where a carbonyl carbon is singly bonded to a nitrogen or either a hydrogen or carbon. Our next one is a secondary amine, also known as amino groups, which is where a nitrogen is bonded to either a hydrogen and two other R groups. It has a tertiary amine, which is a nitrogen bonded to three R groups. We have two cycloalkenes. Cycloalkenes contain carbons connected by one or more double bonds that don't form an aromatic ring. We also have an aromatic group. Aromatic groups have a conjugated pi system that is planar and has alternating double and single bonds. There is also an aromatic amine and an enamine. So why did I choose this molecule? If you haven't heard of LSD, you've probably been living under a rock. There was a whole hippie era in the 1960s and 70s that was because of this mood-altering and psychedelic drug. It is known for its psychological effects like altered thinking processes, closed and open eye visuals, synesthesia, which is the experience of one of your senses through another. For example, when you hear music and you see shapes. A sense of time distortion, ego death, and spiritual experiences. It's mainly used for recreational use in psychedelic therapy. It's also non-toxic and non-addictive, meaning it has many implications in medical treatments like psychedelic therapy. LSD is a semi-synthetic psychedelic drug of the ergoline family. It's a potent hallucinogenic drug, serotonin agonist and antagonist. It's non-addictive and non-toxic. It's illegal to administer, manufacture, buy, possess, process, distribute without license from the DEA. Its properties are: the form is pointed prisms from benzene, it's tasteless, odorless, and colorless, its melting point is 176 to 185 Fahrenheit, it's water-soluble and sensitive to both light and heat. LSD is used in assisted therapy, which is non-FDA approved. For example, a recent study showed the safety and efficacy of psychotherapy in patients with anxiety from life-threatening diseases. After 12 months of psychotherapy, 77.8% of participants reported a reduction in anxiety and 66.7% reported a rise in quality of life. LSD can be taken orally as a capsule or tablet, can be snorted or injected in a vein, or dried onto gelatin sheets, pieces of blotting paper, or sugar cubes. Just as a little fun fact, Albert Hofmann was the first to synthesize LSD from ergot in 1938, which is a grain fungus that grows on rye. Moving on to my reaction, I have demonstrated the synthesis of LSD. The initial compound was treated with thionyl chloride, converting it to an acid chloride molecule, which then undergoes a Friedel-Crafts acylation reaction after adding aluminum chloride, assembling a ketone. Bromination was performed in acidic media. The brominated intermediate is then treated with methylamino acetate, ethylene ketol, and a nonpolar solvent, which gave an alkylated intermediate, which is then hydrolyzed using HCl to deprotect the acetyl. At the same time, the benzoyl group that protects the dihydroindole is removed. The last ketone intermediate is treated with sodium methoxide and methanol. Then there is a nucleophilic addition of this enolate to the other ketone, closing the third and last ring. Then there is an elimination reaction giving rise to the corresponding alpha-beta unsaturated ketone. This compound is then treated with sodium borohydride and sodium anhydride to reduce the ketone group to the alcohol and protects the nitrogen of the dihydroenol. A chloride is then substituted for the alcohol while being treated with thionyl chloride and sulfur dioxide. The chlorinated intermediate was treated with excess sodium cyanide and anhydrous liquid hydrogen cyanide, and the resulting intermediate was treated with acidic methanol to give the corresponding methyl ester. Also, the acetyl protecting group on the nitrogen was removed under the acidic conditions. Ni-Rani and sodium arsenate are used to oxidize the dihydroindole to indole, giving us lysergic acid. The last step is the formation of an amide with diethylamine. And that's it, folks. Here are my references. Thanks for coming to my TED Talk.